Assalamu alaikum, sir. Previously, I have shown the introduction and the classification taxonomy, but due to some technical issue, I cannot carry the presentation. So, hence, I will start from the point where we have stopped. So, the architecture model. So, there are basically three types of architecture model in DDoS attacks. If we consider the model, how they communicate, how the components communicate with each other, the first one is agent handler model, the second one is reflector model, and the third one is P2P based model. So first, the agent handler model. So I have already talked about this. So basically, this is the basically the client. The client is the basically the attacker, and the agents are the basically the bots. So when the a particular attacker want to perform an attack, he commands the agents through the handlers. Handlers is nothing but a software package that infects a network resource located somewhere in the internet and which is used by the client to communicate with agents. So when the agents find when the agents receive the attack information, then they particularly they perform the attack. So the second one is reflector model. Unlike the agent handler model, you can see that the agents does not directly attack the victim. Instead of they are sending the mm, attack, sending the packet to the reflectors. Basically, reflectors are nothing the uninfected machines. So when they are sending the packet to the reflectors, they basically changes the source destination with the destination of the primary victim. So when the reflectors find that the message is from the victim, so they reply to the victim, and hence the resource of the victims become unavailable, and it's turn out to be DDoS. So what is the significance of this attack? In previous the in agent handler model, the agent's ID, the agent's IP can be found as they directly communicate with the victim. But here in the reflector model, the agents are anonymous. So the victim doesn't know the IP address of the agents. So hence hence it is harder to locate the boards that are sending traffic to the reflectors since the packet's source IP address has been spoofed. Uh, then I will show some attack description. Uh, so let's start. There are a few attacks that Mirai can perform. The first one is TCP sync attack, then the DNS sword attack, then DNS amplification attack. I will show these three attacks. So let's start. So here you can see that this is TCP sync attack or sync fraud attack. Basically, this attack is exploitation of the TCP communication, TCP protocol. So the TCP we know that TCP is a three-way handshaking protocol where the sender first send a sync message and the receiver responds with a sync or ACK attack and waiting for the final confirmation. So there is a waiting time from the sync ACK and to the ACK of the sender. So here in the exploration, basically this waiting time is compromised, and the resource is making unavailable to the legitimate user. So here how it is done. See, the attacker first sends a high volume of sync package to the target server, often with the spoof IP address. So the IP address is not valid. This IP address may not exist. So the server responds with a sync or ACK, but as they are not valid address, and they are also waiting for the ACK from the unvalid address. They are still waiting, and the no ACK is coming. So they are waiting until the time is up. So basically, the scenery is like that, where the spoofed sync packet is sending, but the sync ACK uh, is going to the non-existing PCs, and there is no final ACK. And as the sync packets are coming, and the all ports are opening and waiting for the ACK packet, but there is no ACK packet receiving, and finally making the system unavailable. Uh, this is another type of attack, DNS flood attack. So basically, the high bandwidth device like IP cameras and DVR boxes and IoT devices overwhelm the DNS server. As a result, the legitimate user cannot access the DNS server. One things to notice that the IoT device must be a high bandwidth device. The another type of attack is the DNS amplification attack. In DNS flood attack, the device need to be high bandwidth, but in this case, the device need not to be the device can be smaller bandwidth. Basically, it is sending a very small request to the DNS server, where the source address is spoofed, and hence the DNS server reply to the attack victim reply to the victim instead of the attacker, and the attacker overwhelmed with the responses. So basically, two things to be noted, that the request made by the small IoT device are small requests, but for large DNS records. So the reply must be huge amount of files, and the returns address is to the victim. So hence the victim receives a huge amount of traffic, and hence this the traffic from the victim side becomes unable, and makes a denial of service scenario. And the next, I will show how the Mirai communicate, and the component of Mirai. So you can see that the infrastructure of Mirai, which is consist of four components basically: the CNNC server, the Mirai board, and the reporting server, and the loader server. So you can see the logical view of their infrastructure, where these are the basically boards which have been infected through Mirai OM, and this device are communicate through the CNC server uh, by the admin or users. And you can also show that there is a scan procedure, which is basically reproduction phase of the Mirai. We will see that uh, in slides next. And so first we see the CNC server. Here, the CNC server, basically CNC server is the component of the Mirai infrastructure that is used for admins and users to control the botnet and to commerce the boards. So basically, there are three types of user clients. First one is admin, which is the privileged actor, which can create and which has create new user and is scheduling a new attack. And another type of client is user, which is basically the less privileged. He can schedule an attack, but instead but he need to pay some amount of money to the admin. And there is another client, the bot. Basically, the bot is the IoT device that has been infected by the Mirai OM. And these three users are distinguished from two factors: the port which they are connected to, and the first message they send to the CNC server. And the second one is the Mirai board. And Mirai bot, I have already said that Mirai bot is the uh, infected IoT device, uh, and Mirai bot performs some tasks. The tasks are masking itself. So, as a malware, it should mask itself so that other software cannot see this, and then it kills the other process which are using the ports that Mirai uses. And the second is scanning. So the scanning, I have already said that scanning is the reproduction phase. Here it starts a background process of using a wide range of random IP address for possible vulnerabilities IoT devices. So basically, this is the Mirai board, and he is scanning and try to be connected with the other IoT devices using random IP address. And to access access particular devices, it uses a dictionary attack based on 62 entities. As the password of IoT device are poorly secure, and most people don't change, they still remain like admin root 1234. And so these are the vulnerabilities that Mirai uses to reproduce itself. And second, after reproduce a number of Mirai, it waiting for the commands from the CNC, which is basically the commands to attack a particular victim. And the third component is the reporting server. So I have said that the scanning phase, where it scans the vulnerable devices and try to find out the IP address, and try to find out their IP address, their username, and their password. And after finding this, the Mirai report to the reporting server, which basically send to the forward to the load server. So the fourth is the load server. Basically, load server is the component that actually upload the malware to the vulnerable IoT devices. Uh, vulnerable IoT devices. There are three components of the load server. First one is pool of workers. This is basically the threads which are charged of processing the vulnerabilities, and the second one is list of vulnerabilities which are given by the reporting server, and the third one is binary resource code. So basically, these code are basically uploaded to the vulnerable IoT devices, and these are one point, and these are cross compiled. And this is a animation showing the life cycle of Mirai board. The Mirai board, and the phase is reproduction phase. So basically, so let's start the animation. So you can see that first the boards are sending new victims using the brute force attack. And once the new victim is found, it report to the reporting server with the IP address and the username and the password. And the reporting server send it to the load server and say to upload the malware to the victim. So load server then upload the malware, and the new victim runs the malware and join the botnet. And this is the attacking phase, where the CNC server commands to the boards, and see that the CNC server commands to the boards. Basically, the user and the admin are making the command, and once the boards receive the command, they show the scheduling, they show the time when to send the packet to the victims, and the boards carry out DDoS attacks. And last part is that the boards and CNC server continue to communicate for their internal communication. And here is the summary. You can see the summary slide, where these are the boards. First, they are scanning for new victim. When they found vulnerabilities, they send it to the reporting server, and reporting server to load server, and finally load server upload the malware to the victim. And that's how they are reproducing. And this part is basically the performing a particular attack. So CNC servers send the commands to the boards to perform a particular attack. Like we have seen that TCP sync attack, then DNS flood attack, then DNS amplification attacks. So these attacks are, and when these boards find receive the command, they all are performing the attack in their scheduling time, and they are communicate with the boards are communicate with the CNC server for internal communication. Thank you, sir. That was my presentation. Thank you, sir.